workshop. Um, so as we discussed earlier, okay, so in this workshop, what we plan to do is to teach you some math skills that you would need in order to do physics easily within the next 2 years of the course of your study. So we have already discussed several sections. So today we'll start off with something called the proportionality, right? Scaling and power laws, right? So when it comes to proportionality, actually it's like this. Now, there are several physical quantities, right? We have several physical quantities, and those physical quantities are dependent on each other, right? So, for example, if you take, let's say, the pressure, okay, the pressure of a gas, okay. So the pressure of a gas depends on the volume of the gas, right? So there's a certain dependency between those two, right? So here, proportionality is when you have a sort of uh, relationship, where you have a sort of mathematical relationship between them, in which case, like changing one of the uh, quantity would change the other also, okay, in a certain given manner, right? So, for example, you can see in this note, you can see we have given y is proportional to x, right? So, if someone says y is proportional to x, it means that if you increase x, right? If you increase x, uh, y also increases, right? So, for example, if you take x here, you can see we have x here. If you increase this x, right, the value of phi also increases. Now we have another relationship here. It is y is proportional to x squared, right? Y is proportional to x squared. So here also, when you increase x, y also increases. But if we compare these two, if you take y is proportional to x, and y is proportional to x squared, if you compare these two, right? So you'll see the dependency is slightly different, right? Now, when it is proportional to x, the idea is like this. For example, let's say I multiply x by 2. Then what happens? Y gets multiplied by 2, right? So if you multiply x by 2, y also gets multiplied by, right? So they are dependent on each other, but if you multiply 1 by 2, y also gets multiplied by 2, right? That's the idea of y is proportional to x, right? But if you take y is proportional to x squared, that means when you multiply x by 2, right? What happens is y gets multiplied by not 2, but by the square of 2. Okay, y gets multiplied by 2 squared, the square of 2, right? So if you multiply x 2 times, okay, you get y multiplied square of 2 times, right? So, for example, if you consider uh, a relationship like y is proportional to x to the power 4. In this case, when you multiply x by 2 times, right? When you multiply x by 2 times, what happens is y gets multiplied by 2 to the power 4 times. This is the idea, right? So this is the idea of proportionality, and it works for division also, right? When you divide x by 2, now for example, for y is proportional to x, right? When you divide x by 2, y also gets divided by 2, right? And for y is proportional to x squared, when you divide x by 2, y gets divided by 2 squared, right? So y is proportional to x to the power 4. Then in that case, when you divide x by 2, y gets divided by 2 to the power 4, right? So this is something that you should understand. Also, there's another, now these two types, no, not like the proportionalities we have here. Now these can be classified as directly proportional. Okay? These types of proportionality are called directly proportional. Okay? We call it directly proportional because when you increase one quantity, the other quantity also increases, right? But there are other relationships where, like this, for example, y is proportional to 1 over x, right? Here, what happens is when you increase one quantity, the other quantity decreases. When you decrease the other quantity increases, right? So this happens. So such relationships are called inversely proportional. Inversely proportional, right? So it works like this. Now, if we have this relationship y is proportional to 1 over x, if I multiply x by 2, okay, if I multiply x by 2, what happens is y gets divided by 2. Okay? If you multiply x by 2, y gets divided by 2, right? On the other hand, let's say we have a relationship called y is proportional to 1 over x squared. In that case, when I multiply x by 2, multiply x by 2, y gets y gets divided by 2 squared. So this is the idea of proportionality. This is inversely proportional, right? So when you have inverse proportionality, what happens is when you multiply something by a certain value, uh, the other quantity gets divided by that same quantity, right? Or if you have something like y is proportional to 1 over x squared, when you multiply x by something, the other quantity y would get divided by the square of 2, right? So it works the other way around also. For example, if you divide x by 2, okay, you divide x by 2, y gets multiplied by 2. Okay, so that's the idea. And also, if you divide now for y is proportional to 1 over x squared, if you divide x by 2, what happens is y gets multiplied by the square of 2, right? So this is the basic idea of proportionality, right? When we say that two quantities are proportional to each other, this is what it means, right? Either they can be directly proportional or they can be inversely proportional, right? So this is a manner in which we can say a certain quantity increases with the other or decreases with the other, right? So now we can move into some examples. Before that, I have another point to say as well. Like if you have a proportionality equation, like if you have a proportionality like this, uh, you can say we can convert it into an equation, right? If you have a proportionality like this, we can convert it into an equation like this. Instead of the proportionality, you can get equal sign, but What you have to do is you have to bring a constant, a proportionality constant here, and multiply it with x. By doing this, you can get an equation. So k is a constant, right? So if I say y is proportional to x to the power 2, then y is equal to kx squared. Or if I say y is proportional to 1 over x, then y equals to k times 1 over x, which will be k over x. If y is proportional to 1 over x squared, y equals to k over x squared, right? So this is what you'll get. So you should have this idea also. So first thing, like you should understand how proportionality works, right? So you have both types. One is directly proportional, the other one is inversely proportional. So if it is directly proportional, you can see if you multiply the value, the other quantity also gets multiplied, right? Uh, on the other hand, if you have inversely proportional, if you multiply one quantity, the other quantity gets divided, and if you divide the quantity, the other quantity becomes, or the other quantity gets multiplied, right? So that idea should be present. So yeah, let's move into some examples. Let's see how we can work on this, right? So in some cases, they'll just give you the relationship. Uh, Now it's like this. So for different situations, for different physical quantities, there'll be different types of relationship, right? So by looking at the relationships itself, we can say whether there is a proportionality or not. Okay. So for example, now if you consider this worked example, the first worked example, okay? So if you consider the first worked example here, you can say um, it says the distance traveled by an accelerating drawn follows d equals kt squared. Okay, so d equals kt squared. Now you can see just by looking at the relationship, you can see d equals k. K is a certain constant. Okay, times t squared, right? So from that you can understand that d follows, or d is proportional to the square of t. Okay, d is proportional to the square of t. So you can understand the proportionality here. D depends on the square of t. So what happens is if I multiply t by 2, okay, by any chance, if I multiply t by 2, d gets multiplied by 2 square. Okay, or if I multiply t by 3, d gets multiplied by 3 square. Okay, if I multiply t by 5, d gets multiplied by 5 square. That's how this works, right? So the distance traveled by an accelerating drone follows d equals kt squared. Now they've given a certain situation. They say at t equals 4 seconds, d is 32 meters, it seems. Find the distance when t equals 7 seconds, right? So they've given the value when the t is 4 seconds, and they are expecting us to find the distance when t equals to 7 seconds. So let's see how we can work this out. So here they have given a certain method. We can do it a little uh, like in a shorter way, okay, than this also. So we'll consider that also. First of all, we'll focus on this. So you can see it's given as like d equals 32 meters and t equals 4 seconds. So when d equals kt squared, you can see we can substitute. So 32 becomes equal to k times the square of 4, right? So d equals, so 32 equals to 16k. 4 square is 16, so 32 equals 16k. K equals to 32 by 16, which is 2. So we've got the value for k, which is 2. Now we can rewrite the expression d equals to, now instead of k, now we know the value of k, right? So I can put 2. So d equals 2t squared, and when t equals 7, I can plug that in this expression. So d equals to 2 times square of 7. So square of 7 is 49. So 2 into 49 is 98. So the answer would be 98 meters, right? So now you can see we can do it like this. So I can just write the relationship. The proportionality relationship is d is proportional to t squared. No? So I can write that relationship, and then they've said for t equals 4, it's 32, right? D is 32. So we can see 32 is proportional to 4 square, right? Then they're asking us to find the d value for 7, right? So 7 square. So 32 is proportional to 4 squared and d is proportional to 7 squared. These are the two equations. What I can do is I can divide one of the equation by the other. Okay? I can divide these two relationships by one another. And you can see you will get 32 divided by d equals to 4 squared over 7 squared. So you can cross multiply. I can take d to the other side, 7 squared to this side. So 32 into 7 squared equals to 4 squared into, right? So d equals to 32 into 7 squared divided by 4 squared is 16. 32 by 16 is 2. 2 into 7 squared is 49. That's 98 meters. So we can do it like this also, whichever is convenient to you. Right? In this method, you don't have to find k. You can just directly get into d. Okay, just by using the relationship, you can get to the answer of d. Right? So now this is a situation where you have to find a certain value based on given other values, right? So sometimes they won't just give values. Okay, sometimes they won't be just giving you the exact values. They might ask you like how the quantity changes. Okay, how the quantity changes. So that I have already told you, right? Like when we started the discussion, uh, we I thought that like it's like this. So you multiply some like one of the quantity by a certain value, and the other quantity gets multiplied or divided according to the relationship. So you can see the second worked example. Now in that they've said the light intensity follows I is proportional to 1 over r square, right? So you can see we have a relationship like this. I is proportional to 1 over r squared, it seems. Okay, so you can see here it's an inverse proportion, right? So it's an inverse proportionality, right? So what happens is when you multiply r by a certain factor, I gets divided by a certain factor. So, for example, in this question they've asked if the distance becomes 3 times larger. So what you're doing is you're multiplying r by 3. R by 3. So if you multiply r by 3, what happens is, right, I gets divided by the square of 3 because it's 1 over r squared. So I gets divided by the square of 3. So which means I gets divided by 9. I gets divided by 9. Okay, so you can say the intensity becomes 1 over ninth of the original value. Okay, um, now if the intensity, for example, if the intensity was 90, okay, if it was 90, now it will become 10 because it gets divided by 9, right? It gets to the 1/9 of the original value, right? So that's what happens. Right now they have there's another relationship, there's another example you can see. The kinetic energy follows, okay, uh, this relationship E is proportional to V squared. So actually the equation for kinetic energy is E equals half mv squared. It is the usual equation, right? You can see half m, half into m. Half is just a value, and m is mass, right? M is the mass, right? It's the mass. So if the mass doesn't change, or if we can, or in other words, we can say the mass is constant. So if the mass is constant, then this half m is a constant value, right? So it's like E equals some constant times v squared. So if you have a relationship like this, so E equals to half m into v squared. Now half m is a constant into v squared, right? So I can take it as E equals kv squared. Okay, some constant value into v squared. Now, if you have it like that, you can say E is proportional to v squared, right? So if there is just a constant like this, and you have a quantity v squared, that means E is proportional to v squared. That is what they have said here. Okay, so you should be able to figure this out on your own, right? So E is proportional to v squared. So it's a direct proportionality, right? It's directly proportional, right? So now you can see if it's directly proportional, easily we can say if now v is the speed, so v is the speed. So if it doubles, okay, so if v doubles, okay, if v doubles, e gets multiplied by, now you multiply v by 2, right? So in that case, e gets multiplied by the square of 2, which is 4, right? So you can see e gets multiplied by square of 2, which is 4, right? So E gets the energy, E is energy, okay? So E gets multiplied by 4 times. So energy becomes 4 times larger. That's the idea, right? So relationships like this are something very common in physics, okay? So if you take the MCQ paper, you will have uh, several questions like this. Now the thing is, now they won't be giving you these relationships, right? So in theory, you'll have to study those relationships, keep them in your mind, and then in the paper, you'll have to apply those, right? So in these questions, you see, we have given the relationships because you haven't studied this stuff yet. But later on in your final paper, the relationships also should be figured out by you. Okay, you should figure out the relationship, and you should understand what sort of proportionality exists, right? Whether it's directly proportional, whether it's inversely proportional. So based on the relationship, you should be able to figure out what happens when you increase a certain quantity or decrease a certain quantity, uh, and so on. So you should be able to figure that out, right? So let's go into some more questions, just few more practice problems. Um, we'll just do one or two, right? So, so you can see uh, we have third question. So rotational energy. Energy follows E equals k omega squared. Okay? E equals k times this letter is called omega. So omega squared. right? So in other words, we can say E is proportional to square of omega, right? Omega squared, right? Now you can say we can substitute. So omega is 4. When omega is 4, E is 64. So 64 is proportional to the square of 4, right? And then we can say energy is proportional to 9 squared. We have to find the energy when omega is 9, right? So we'll take the relationship. Now 64 is proportional to 4 squared, E is proportional to 9 squared. So we can divide these two relationships. So when you divide, what happens is you can get something like this. 64 divided by E will be equal to, okay, when you divide, you can get this like this. So 4 squared over 9 squared. So now you can take E to the other side. E is equal to, that means I bring E to the other side. So cross multiply actually. So like this. So E gets multiplied with 4 squared and 64 gets multiplied by 9 squared. E equals to 64 into 9 squared over 16, right? 4 squared is 16. I bring it to the other side. So 64 by 16 is 4. 4 into 9 squared is 81. 4 into 81 is 364. Okay, so E equals to 300 and, 324, right? E is equal to 324. Okay, so now another question is like, um, so for example, now in these questions you don't find one such, but I just ask you like this. So what if, uh, okay, so what if you have a relationship like this? Now, okay, let me just go through just one of the given one itself. So they have said extension follows uh, this relationship x equals af. So x is proportional to f, and here they have said a force of 6 Newton produces an extension of 3. Uh, find the extension when the force is 15. Yeah, this type of question is what I was trying to say. Now here, uh, now the force is given for two situations, right? And they're asking us for the extension. Now let me just flip this question a little. What if they ask what is the force for extension of, let's say, 10 centimeters? What if they ask something like this? What is the force for extension of 10 centimeters? Right? So you can see we have x equals kf, or x is proportional to f. So in this case, the given data says that a force of 6 Newton produces an extension of 3. So 3 is proportional to 6. This is the first one. Now they're asking us uh, what's the force for extension of 10. So we have the extension that is 10. They're asking us for the force, right? So you can have something like this also, right? So they'll be giving the one here in this side. They'll be asking for the one in the other side. So that's also something common, right? So you can say 3 over 10 equals to 6 over x. You divide these two, the first equation by the second. So 3 over 10 equals 6 over f, and you can cross multiply. So 3f equals 6 into 10, which is 60. F equals to 20. Okay. So You can do it like this also, right? Okay. So in addition to that, you can see uh, they have given questions like this. So we'll just go through one or two of these two. So they've said the fifth one, wave energy. Okay, wave energy. The energy transported by a wave follows E is proportional to a square. Okay, so if the amplitude triples, find the factor change in energy. Okay, so you can see uh, E is proportional to a square, right? E is proportional to a square, and we are increasing a by multiplying it by 3. It's tripled, right? So a gets multiplied by 3, multiplied by 3. Then what happens to e? Then e gets, now this is direct proportionality. So e also gets multiplied by not 3, but the square of 3, which is 9. Okay. So energy increases by, e increases by 9 times. Okay. So e increases by a factor of 9, right? That's right. So right. So let's say mm, signal strength follows signal strength follows 1 over d square. Okay, d is distance. Okay, if the distance becomes 4 times larger, right? So you can see this is an inverse proportionality, right? So you can see when d gets multiplied by 4, by 4, when d gets multiplied by 4, s should get s gets divided, okay, not multiplied here because it's inverse proportionality. Hope you remember. So when d gets multiplied by 4, s gets divided by, now here it's s is proportional to 1 over d squared. It gets divided by the square of, which is 16. So s reduces by a factor of 16, right? That's the idea. Okay. So in addition to that, now here we have always been focusing on the in the multiplication or the factor change, right? So they say that it gets larger by a certain factor or it gets smaller by a certain factor. So they say something like that. In addition to that, they can say the increase in a certain quantity as a percentage. They can say the quantity increases by this much of percentage, or it decreases by this much of percentage. So that also could be said. So let's focus on that also quickly. For example, if they say, oh, we have E is proportional to V squared, which is a relationship, and they say this V, the speed, V increases by 50%. Okay. Supposed to be 50%, 25%. Okay. Volume increases by 50%. Okay. So V increases by 50%. Okay. So from that you should understand now when V increases by 50%, it means now V is V now. And when it increases by 50%, what happens is it becomes 150 out of 100% of the V, right? It becomes 150 over 100 of V, right? So V was the initial value. Once you increase it by 50%, what happens is it becomes 150 out of 100 of V, right? So 150 out of 100 means it's 1.5 times V. So earlier it was V, now it is 1.5 V, right? So that's what happens here. Like if for another example, let's say if they say V increases by, let's say 24%. Okay, if they say V increases by 24%, V would become 124 over 100. Okay, V would become 124 over 100 V, right? So something like that. So V is 1.5 V now. Now we can see, right? Uh, they said E is proportional to V squared now, right? E is proportional to V squared. Now initially E is, let's say E itself. Okay, initially it's E for V, right? So this is the first relationship. This is the initial situation. Initially, uh, when velocity is V, the energy is E. Let's just take that value itself. Now V becomes 1.5 V. Now it's 1.5 V, right? So now we have to square that. The new value of V is 1.5 V, right? The new value of V is 1.5 V. So now we have to square that. So 1.5 V squared. That is proportional to the new energy now. Okay, now when you increase the velocity, the energy also increases now. So the new value that you have is proportional to 1.5 V squared, right? So that's the second one. So now what I can do is I can divide one by the other. So E divided by En is equal to V squared over 1.5 V whole thing squared is, now 1.5 squared is 2.25 V squared. So when you have 1.5 V squared, I'll have to square 1.5 and then I have to square V squared. Okay, I have to square V, so I get V squared. So I have to square both these. So 1.5 squared V squared. 1.5 squared is 2.25. Okay. So V squared cancels off. I can take En to the other side. So cross multiply. So 2.25 to this side, En to the other side. Here we just have 1. So 2.25 E equals to En. So new E is 2.25 times E. 2.25 as a fraction I can write it's 225 out of 100 E, right? It's 225 out of 100 E. That means I can see if the increase is 50%, we write it as 150 over 100, right? If it is an increase of 80%, we can write it as 180 over 100 times that quantity. So here you can see, now we add that percentage increase with 100, right? So 80% increase means 180 over 100. 225 over 100 means it's 125% increase in E. Okay. So when you increase E by 50%, E gets increased by 125%, right? That's the idea. right? I hope it's clear. Okay. So we'll get to another question also, something related to this. Okay. So they are saying if x decreases by 25%, find the factor changing value. Question number 10. Okay. A quantity follows y is proportional to 1 over x. And in this case, if x decreases by 25%, find the factor change in y. Okay. So now it's decreasing by 25%. So x decreases by 25%. So x, uh, now earlier, let's say it was x, now it becomes, now when you increase, you just have to add with 100. So it's 50% increase means it's 150 over 100. If you decrease, it should be subtracted from 100. So 75 out of 100. Okay. That means you divide and you subtract 25 from 100. So 75 over 100 of x is what you have. Okay. So 25% decrease means 75 over 100 x. 75 over 100, I can simplify 75. I can divide it by 25, you get 3. Divide 100 by 25, you get 4. So it's 3/4 of x, right? Um, right. So that's the factor change in x. That, I mean, that's the change in x. Now x becomes 3/4 of x. So let's see what happens to y. So earlier y is proportional to 1 over x. So if you have x, then it's y, right? Now the new value of y is for the new value of x. Now x becomes 3/4 of x. 3/4 of x. Right? So we can say when you divide something like this, 1 over 3/4 of x, what you can do is you can uh, actually in this case you're just flipping the fraction. So you take 4 up and put 3 down. Okay. So it's supposed to be 4 over 3x. Okay. The 4 goes up, 3 remains. Okay. So it's 4 over 3x. That's the second relationship. So what I can do is I can divide one by the other. So I'll get y upon y1 equals to 1 over x divided by 4 by 3x. So this x cancels with this x. This 3 can be taken up, right? So this 3 can be taken up and you'll have 4 down. So it's 3, 4. Okay. We can see y over y1 is 3 over 4. We'll take y1 to the other side. So y1 times 3 equals to 4y. So y1 equals to 4y over 3. Okay. That's the new value of y. Okay. So y1 is 4 over 3y. Okay. So 4 over 3 is around 1.33. Okay. 1.33. Okay. Okay. So 4 by 3 is 1.33y, which is 133 over 100y. So y increases by 33%. Okay, that's the idea. So you can see if you decrease x by 25%, now the y becomes 4 by 3y. Okay, so if they ask what's the new value of y, you can say it's 4 by 3y. You can stop there. If they ask what's the increase in y, what's the percentage increase in y, you will have to get the decimal like that, decimal value. 4 by 3 is 1.33. So as a fraction, you can write it as 133 over 100. So in that case, you can say now it's 133 now. So 33 added with 100. So we can say y increases by 33%, right? So this is how we deal with proportionality, and this is something that you will come across in several questions, especially in the multiple choice question in the part one of the paper, right? So that's it for this section. So under proportionality, these are the stuff we have. So please practice more questions so that you'll be able to do them quickly without taking much time. So with practice, you can just get some simple ideas of doing this. Okay. So here I just went uh, like we just did according to the you know according to this equation itself, but you don't have to, I mean, do get these equations itself. You can just uh, you know figure that out, figure the increase or decrease or whatever happens just by looking at the relationships without forming these equations. That comes with practice, right? So if you get to that level, you can just save a lot of time. Okay? Right, so that's it. So we'll move to the next section. So that's it for proportionality.